Alright, welcome to Colossal Mathematics class. Don't forget to subscribe, like and share this video. In today's class we're talking about differentiation. Now, what is differentiation? You know, in our last class we spoke about gradients and all these other things. I get what I'm saying. So differentiation or derivative, are you saying that the topic is differentiation, but when you have something like y equals to let's just leave it as read. When you have y equals to f of x, I get what I'm saying now. This f prime, then we have y prime equal to what? F prime. I using that it can be f prime, it can be y prime, depending on what you have. This f prime is what we call the derivative. I get what I'm saying now. F prime is called the derivative, and f prime means the derivative of f of x. Y prime means the derivative of y. I get what I'm saying. And what is derivative? Derivative is the gradient. Don't forget, we said that gradient m in our classes. We said gradient m is what? Change. We said it is what? Change in what? In y axis over what? Over change in what? In x axis. Are you seeing that? Which we said is what? Is y2 minus what? y1 over what? x2 minus what? x1. Are you seeing? So that gradient, that change, the change in the gradient is what we call the derivative. I get what I'm saying. So the derivative of f of x is the gradient function of the curve. Did you get that? The derivative of f of x is the gradient of the what? Of the curve. I get what I'm saying. And then we said if y, so now if y is equals to what? F of x. Are you seeing that? If y is equal to f of x, then dy dx, this is what we mean by derivative of x. This change in y over change in x is the same thing as what? As dy dx. Are you seeing that now? And dy dx is equal to what? F prime. You know, I already said that f prime of what? Of x. So if I don't want to write f prime of x, you know, this dy dx is the same thing as saying this y prime that is here. Are you seeing that? So I can say that instead of writing y prime, I can say dy dx. So instead of writing f prime, what will that be? I can now say that this is what? Df. Are you seeing that? Df dx. Are you seeing that now? So this is what differentiation is all about. I get what I'm saying. And when you see d like df like this, it means you call it df. Are you seeing? We call it df dx. Are you seeing that? Df dx. We don't say df over dx. I get what I'm saying. As a mathematics student, once you say df dx, whoever you are talking to knows that you are saying df over dx. Are you seeing that now? So what will this one now be now? This one, what will it be? It will be what? Dy what? Dx. Are you seeing that now? So you don't need to be saying dy over dx every time. Once you say dy dx, we know what you are referring to. All right. So now let's see basic differentiation technique. We want to see the basic differentiation technique. The first one is that, so let's hold it like this. If you have y here and then you have the derivative here, so here you have dy dx. Are you seeing that? You have dy. Let me clean that. So here you have dy dx. All right. So now if y is equal to, if you have y like this and it is equal to x raised to power n, that means your dy dx will be what? You will draw this n like this, then you write your x, and then you subtract 1 from the power n minus 1. This is the first rule. Now what does that mean? That means if I have an example like y is equals to x raised to power 5, find dy dx. What will be the dy dx? I will drop 5, then what? X, then what? 5 minus what? 1. That means my dy dx is what? 5x raised to power what? 4. Do you understand that now? look at another example. If I have y equal to what, let's say y equal to 2. No, don't let me use 2 yet. Let me say y equal to x raised to power 3 now. What will it be now? It will be what? 3x. 3 minus 1, 2. Are you seeing that? So that's the number 1 rule. Now number 2 rule says that if I now have y equal to ax raised to power what? Power n, it will still be the same thing as what? As a multiplied by what? N x raised to power what? N minus 1. That means if I have like y equal to what? 3x raised to power 4. I think that 3x raised to power 4, that will now be what? 3 times what? Times 4. Then x raised to power 4 minus 1, 3. I think that. So this will now be what? 12x raised to power what? 3. Are you seeing that now? So that is the derivative of this. So what if I have something like y equals to 7x squared? What will it be? 7x squared. That will become what? That will become dy. Our dy dx. Our dy dx will be what? If you differentiate 7, that's 2 times 7, 14. Are you seeing that now? Then x raised to power what? 2 minus 1, 1. That's the same thing as what? 14x. Do you see that? Look at the last one. Let's say I have y equal to, let me see a longer example now. Let's say I have y equals to 6x squared plus 7x. No, let me not say 7x. Let me just leave it as 6x squared. No, let's use 6x raised to power 5 now. I see 6x raised to power 5. What will be your dy dx? Your dy dx will be what now? It will be what? 5 times 6, 30. I think that 5 times 6 is what? Is 30. Then x raised to power what? 5 minus 1. That's what? 4. Do you understand that now? So that means your answer here is what? 30x raised to power what? Power 4. Alright. So now let's continue the rule. So we have another rule. Alright. We are not through with the rule yet. Today we are looking at the table. So the number 3 says if I have kx, if y is equal to kx, and I want to find the derivative of kx, what will be the derivative? The derivative will be what? K. Are you seeing that? The derivative will be what? K. That means if I have example like y is equal to 3x and I want to find the derivative of 3x, that will just be what? That will be the same thing as what? As 3. Are you seeing? Do you know why it is like that? The reason it is like that is because, we said the natural differentiation is something like n, it is generally as n x raised to power what? Power n. Are you seeing that? If I have x raised to power what? If I have x raised to power n, then we say the derivative is what? N x raised to power what? N minus 1. Are you seeing that? Now 3x is the same thing as what? As 3x raised to power what? Power 1. Yes or yes? And that's the same thing as what? As 3x 1 times 3 is 3. That's why you can see this 3 that is here. Then 1 minus what? 1 minus 1 abi, which is equal to what? 3x raised to power what? Power 0. And anything raised to power 0 is what? 1. So that means this is the same thing as what? As 3 times what? 1, which is what? 3. So that's why the rule of differentiation is saying that anytime you have kx, just know that you will get what? K. That means whenever you have a number and x and you want to find the derivative, it will just be what? That number. Are you seeing that now? So that means if I have something like, are you seeing that now? That means if I have something like let's say I have y equal to 10x now. Are you seeing? What will be your dy dx? Your dy dx will be what? 10. Are you seeing? What if I have y equal to 0.2x? If you want to find the derivative, 0.2x, what will be the derivative? 0.2. You just know that the x will leave. Are you seeing that now? All right, so now let's come back to our rule again. We have number 4 rule, which says that if I differentiate a constant k, if I differentiate a constant, that means any number that is not having x, if I differentiate the constant, I will get 0. That means if y is equal to what? 4, dy dx will be what? 0. Are you seeing that now? If y is equal to what? 9, or let's say 9.5 safe. If y is equal to 9.5, as far as it's not having x, the dy dx will be what? 0. Do you copy that now? All right, so now let's see a general example. Now that we've already seen about 4 rules, what was the general example there? Let's say I have something like y equal to 5x raised to power 3 plus 4x squared minus 6x plus 10. Are you seeing that? Let's say I have something like this. What will be the dy dx here? Look at it. What will be your dy dx? Your dy dx here is going to be what? 3 times 5. That's what? 15. Abi, then x, 3 minus 1, 2. Are you seeing that now? Plus 2 times 4. That's what? 8. Are you seeing that now? Then x, 2 minus 1 is what? 1. Then minus 6x. If you differentiate 6x, you can see just like this. If you differentiate 6x, what will you get now? If you differentiate 6x, what will you get? You will get 6. Are you seeing that now? Plus, if you differentiate 10, is it having x? No. That means it will become what? 0. Are you seeing that? So that means our dy dx, here is equal to what? 15x squared plus what? 8x minus what? 6. Are you seeing that now? Minus 6. So that is our answer. All right, let's see one more example. Let's say I have y equal to 13x raised to power 2 minus 10x plus 5. Now you can pause the video and solve the example. What will be your dy dx? Your dy dx will be what? 13 times 2. 13 times 2, that will give you what? 26x, because 2 minus 1 is 1. Then minus what? If you differentiate 10x, what will you get? 10. Don't forget constant and x, you will get the constant. Plus, if you differentiate 5, what will you get? 0. Are you seeing that? So that means my dy dx is equal to what? 26x minus what? 10. Now I promise this is the last example. Look at this example now. So let's say I have an example like let's say y is equals to let's take a negative thing now. Let's say y equal to let's say 6x raised to power minus 2 plus 5x raised to power minus 1 minus 15. What will be your dy dx here? Yes, this is a very perfect example. What will be your dy dx? Your dy dx here will be what? Minus 2 times 6 minus 12 x minus 2 minus 1. You know this will become minus 2 minus 1. Don't forget the rule. The rule says if I have x raised to power, don't forget the rule is the rule we are following. The rule says that if I have x raised to power what? N, it will become x raised, it will become what? N x raised to power what? N minus 1. So now that I have minus 2 here, that means to become minus 2. It will become minus 2 minus 1. Are you seeing that? Minus 2 minus 1. Then let me write this my 2 here. Minus 2 minus 1. Abi. Then what? 5 plus 5 times minus 1. That will also give us what? Minus 5. Abi. Then x. Are you seeing? This will become what? Minus 1 minus 1. Are you seeing that now? Minus 15. If you differentiate minus 15, what will you get? You will get 0. That means our dy dx here, our dy dx is now equal to what? Minus 12. That's minus 12 s raised to power what? Minus 2 minus 1 minus 3. Are you seeing that? Minus 5 s raised to power what? Minus 1 minus 1 minus 2. Are you seeing that? That is our answer. Last example, let's say I have y equal to minus 3 s raised to power minus, don't know why my writing is like this morning, minus 3, what's wrong with this pen, minus 3 s raised to power minus 4, s raised to power minus 4 plus, minus 7 s raised to power minus 2. Are you seeing that? What will be the dy dx here? Your dy dx, are you seeing? Your dy dx will be what? Minus 4 times minus 3. Are you seeing? This minus 4 here times this minus 3. That will give you what? Plus 12. Abi. Then x minus 4 minus 1. That will give you what? Minus 5. Are you seeing? You can see that I don't need to go through all these long steps. So I just did this first one like that. I just did this one so that you can get me. It is not always long. Minus 4 minus 1 is minus 5. Then minus 2 times minus 7. That will give us what? Plus 14. Are you seeing that now? Then x raised to power minus 2 minus 1. Now that will give you what? Minus 3. So you can see the correct answer there. You can see that all these things, they are not difficult at all. Are you seeing that now? They are not difficult at all. Alright, so that will be all in today's video. But before we go, let me give you assignments so that you can also see something and practice. So do y equal to 2 s raised to power 3 minus 5 x squared minus 5x squared plus 2. That's number 1. Then number 2, do y equal to 3x plus 3x squared plus x raised to power minus 1. I see that 3x squared plus x raised to power minus 1. Find the dy dx. Then number 3, do y equal to 3x raised to power 4 minus 2x raised to power 3 minus 7x plus 5. So do these 4 questions. And let me know your answer. So feel free to comment your answer in the comment section, and I'll be there to check. The students of God's Love, submit to the right channel, and I'll also be there to mark your answers. Thank you very much for watching. Don't forget to subscribe, like, and share this video. Right.